In this video, let us see one of the important theorem in vector integration, that Green's theorem. So this Green's theorem gives you the relation between line integral and the line integral and the double integral over the region R. So here if you see the statement here where m and n are continuous functions with the partial derivatives, and R is a region from the xy plane we have considered, which is the region bounded by the simple closed curve C. So then the relation integral over C m dx plus n dy is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy. So this gives you the relation between line integral and the double integral. Right? Line integral is taken over the closed curve C and double integral is taken over the region R. This region R is nothing but bounded by this closed curve C. That is, for example, if you consider a region like this is the region R, okay, where this region is enclosed by the curve C. This is the closed curve C. And then here the direction we have to take it in the anti-clockwise direction. Okay, so this is the way, and this gives you, Green's theorem gives you the relation between line integral and the double integral over R. Now let us see one example based on this theorem. So the problem is verify Green's theorem for integral over C 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the boundary of the region defined by x equal to 0, y equal to 0 and x plus y is equal to 1. Now let us consider the region first. So how to consider the region? First we have to draw these three straight lines. So let us consider x, y axis. So x equal to 0 is nothing but y axis and y is equal to 0 is nothing but x axis. And what about x plus y equal to 1? So this will be the straight line joining 1, 0 and 0, 1. Right? And this is the region R. Okay, so this is the region R, and the closed curve C is nothing but, if you take this is to be the origin O, and if this is the point A and if this is the point B, then C is nothing but, the curve C is nothing but O A and then AB and then BO, that is combination of OA plus AB plus BO. Altogether, that is the combination of these three straight lines will give you the closed curve C. And the inside region is represented as R. So now based on this, we have to verify Green's theorem. What do you mean by Green's theorem? Here this is LHS part and this is RHS part, left hand side, right hand side. So first let us evaluate separately, LHS separately, RHS separately, and finally we should say both are same. So that is what the meaning of verify Green's theorem. Right? So first let us start with RHS part. RHS means what? Double integral over R. Double integral over R is nothing but, already we have studied in multiple integrals how to evaluate double integral for a given region. So here what is dou n by dou x minus dou m by dou y? So now let us find what is m and n given in the question. So m is what? M dx. In the question itself it's given m dx. M is nothing but 3x square minus 8y square. Similarly n is nothing but 4y minus 6xy. So let us consider m and n from the given question. Now to evaluate RHS part we need dou m by dou y and dou n by dou x. So dou m by dou y is nothing but, this is minus 16y. Next dou n by dou x is minus 6y. Right? Now we have to subtract it. So now we have to evaluate RHS part, that is double integral dou n by dou x minus dou m by dou y. Here we have calculated as 10y. So 10y into dx dy. Right? So that what we can do here is, now for this region R, this double integral, we have to find out the limits. So since we have taken the order as dx dy, so we have to first find out the limits for x and then for y. So to evaluate the limits for x, we have to consider strip parallel to x-axis, that is horizontal strip. So now this strip, left end of the strip touches the y-axis, right end touches the straight line. So left end touches x is equal to 0 y-axis. So here the lower limit should be 0 to the upper limit is from equation x plus y is equal to 1, we want x. So x will be equal to 1 minus y. So that here the upper limit will be 1 minus y. Now this is the limit, we have to replace it over here, 0 to 1 minus y. What about limit for y? How long we can move the strip from bottom to top? Bottom it starts from y is equal to 0. So the lower limit of y is 0 up to this particular point B. The point B represents 0, 1 is nothing but here y takes the value 1. So the limit for the strip to move along y axis is, along y direction is still y is equal to 1. So we can take the upper limit as 1. So here we can take 0 to 1 here. So by considering these as limits, we have to evaluate this double integral over R. So this is what we have to integrate it. So first let us integrate with respect to the inner derivative dx. So 0 to 1, since we have to integrate with respect to x, remaining variable are considered as constant. So 10y is treated as constant. So integral dx is nothing but x over the limit is 0 to 1 minus y into dy. One more derivative is there for this integral, that we can do it later. First let us complete this part. So integral 0 to 1, 10y, here upper limit minus lower limit is 0. So this will be the term. Now already 10y is there. So we have to multiply here. So 0 to 1, 10y minus 10y square into dy. So this is equal to, now we can integrate. Now it becomes totally a function of y. With respect to y, we can easily integrate it. So integration of 10y is, we can take 10 common. So integration of y is y square by 2 minus integration of y square is y cube by 3 over the limit is 0 to 1. Right? So this is equal to 10 into upper limit is 1, lower limit is 0. So this is upper limit minus lower limit is 0. So this is equal to 10 into what? Taking LCM, 3 minus 2 divided by 6. So 10 by 6 is nothing but 5 by 3. So now we have calculated RHS is equal to 5 by 3. Now we have to prove LHS is also equal to 5 by 3. Now to calculate LHS part, LHS is integral over C m dx plus n dy. M and n can be taken from the question. So now how to evaluate integral over C? But if you look at the diagram, I told you that C is the combination of OA plus AB plus BO. So while finding integral over C, we have to find integral over A plus integral over AB, that is OA plus integral over AB plus integral over BO. So we have to evaluate 3 line integral along 3 different straight line. Then we have to add it, that will give you integral over C m dx plus n dy. So here first, what is m dx plus n dy? M is nothing but 3x square minus 8y square into dx plus n is 4y minus 6xy into dy. Right? So now first let us calculate along OA. Along OA, OA is the line x-axis, which means that y is taken as 0, y is equal to 0. If y is equal to 0, dy is also 0. Right? So now we have to evaluate along A, since dy is equal to 0, that is m dx plus n dy becomes what? Integral. Since dy is equal to 0, here the second term won't come, into dy will become 0. So we will be left with 3x square, and what happened to 8y square? Y is also 0. So simply we will be having 3x square dx. Okay. Now what about the limit here? Limit is, we want the limit for the variable x. So for this line OA, x varies from, this is the origin 0 0, this is the point 1 comma 0, and this is the point 0 comma 1. So if you see the line O and A, x varies from 0 to 1. Y coordinate, if you see, it is 0 fixed, whereas x coordinate is 0 for origin and 1 for A. So which means that x varies from 0 to 1. So we can say that the limit of x is 0 to 1. So while evaluating here, you put the limit as 0 to 1. Now you integrate it. While integrating it, it becomes 3x cube by 3 over the limit 0 to 1. So the answer is 1. Okay. Now to evaluate along AB, the equation is x plus y is equal to 1 is the line AB. So from this we need to take y is equal to 1 minus x, which gives you dy is equal to minus dx. And moreover, the limit for x is 1 to 0. So how to evaluate or how to identify the limit here? This is A, this is B. So this is 0 comma 1 and this is 1 comma 0, right? We have taken the direction from A to B like this, and this is the line x plus y equal to 1. So now, since we have converted y and dy in terms of x, your integration is in terms of x alone. You can see this integration term. There is no y variable. Now we want the limit for x. So see here, the x coordinate for the point A is 1 and for the point B is 0. So we can say that x varies from 1 to 0. So that is what here we have taken, x varies from 1 to 0. Similarly here you can take the limit as 1 to 0. Now you simplify this whole thing so that you will be getting minus 12 plus 26x minus 11x square. That is, you have to expand this term also. 1 minus 2x plus x square. So if you see the constant term here, minus 8, and then here 4 into minus dx is here. So minus 8 minus 4 is minus 12. So we are having minus 12 dx. Similarly, you collect all the x terms. X terms is what? 8 into minus 2 is 16. And then here minus 4x minus 6x is minus 10. So totally 16 plus 10 is 26. Right? So 26 means how much? Plus 26. Okay. Similarly, we can combine the x square term also. Okay. So after integrating it, 12x 26x square by 2 minus 11x cube by 3, the limit is 1 to 0. So upper limit is 0 minus lower limit is 1. So 12 plus 13, this we can cancel, and then minus 11 by 3. So this is the upper limit and this is the lower limit, equal to, after simplification we'll be getting the answer as 8 by 3. Now we have to evaluate along OA, already evaluated, and along AB is also already, now we have found out. Next we have to find out BO. So the next is along BO we have to calculate. Now along BO, BO is the y-axis which is considered as the line x equal to 0. So x equal to 0 means what? dx is equal to 0. dx is equal to 0. Now you'll be having integration in terms of y alone. So we want to find out the limit for y. So if you notice the coordinate point of y for B and O, B it is 1, to O is 0. So we have to move from B to O, so that 1 to 0 will be the limit for y. So integral along BO, same mdx plus ndy can be written as integral 1 to 0 mdx plus ndy, means in that mdx plus ndy you have to put x equal to 0 and dx is equal to 0. So you'll be getting 4y dy. So now we can easily integrate it. So 4y square by 2, 1 to 0. So 2 we can cancel here. So the answer is what? Upper limit minus lower limit. So 2 is here. Upper limit is 0 minus lower limit is 1. So the answer is finally minus 2. Right? So now what are the values we calculated? Along C is nothing but along OA plus along AB plus along BO. So here the first value is along OA, the answer is 1, and the next answer is plus 8 by 3, and this is minus 2. So on simplification this gives you 5 by 3. So what is this? LHS is calculated as 5 by 3. So already we have found out RHS is equal to 5 by 3, and hence we can conclude that LHS is equal to RHS, that is left hand side part is equal to right hand side part, and hence Green's theorem is verified. So this is the way we have to verify the Green's theorem for the given problem.